All right, so that's 2, 3 is talking about correlation. Correlation is this value that's going to help us relate our two variables, talk about how strongly they're correlated to each other, and again, just building the overall relationship. All right. So here are what correlation is. So the correlation is this letter R, okay? And again, it measures the strength and the direction of a linear relationship. All right, strength and direction of a linear relationship between two quantitative variables. So, um, first off, it has to be between -1 and 1. Okay, so this is very important. So you can't have something outside of these two limits. Of course, if it's a negative R value, it's less than 0, positive greater than 0. That should be self-explanatory. And then here, talking about strength, right? So these two ideas talk about strength. If there's very little scatter, excuse me, from the line, that means all your points are tightly packed around this line, then R is going to be close to 1 or -1. That means you're a pretty strong correlation, right? Because your dots all kind of follow the linear pattern. But if there's more scatter from the line, then your R is going to be close to 0. And that means you're weaker. You don't have much of a pattern going on. They're just kind of sporadic dots. So be aware of that. Okie doke. All right, here's a graph of some just examples of some correlations. So again, you see these scattered dots, the correlation is going to be 0. So I really couldn't draw a linear pattern through here. Over here to the right, so notice these dots are pretty spread out too, but I could, let me change the red. I think I could draw like a line going this way, right? That'd be a negative correlation, but it's not very strong, so notice how it's kind of close to 0. Now we're getting a little bit tighter together, but now we're going this way with it. So now we've turned positive, but again, we're getting farther away from 0. Again, getting even tighter, but now we're going again back this way. So we're back to negative, but again, we're getting closer to -1. Then we have even tighter, but now we're positive, so we're getting close to +1. And again, look at how tightly packed these are. So there's that line. Almost all the dots fit on that line. So but we're negative, so we're very close to -0.99. So just to emphasize more about this correlation, you're going to do an activity on guess the correlation. It's on Edulastic. So I want you to pause this video, go do the activity, and then come back to this video. Okay. So again, this activity is on Edulastic. All right. Okay, so now that you're back from the video, we're going to go ahead and do the example 1. So it says saving manatees choosing a seat. For each of the following relationships, is R greater than 0 or less than 0? Is it closer to R equals 1 or R equals plus or minus 1? Explain your reasonings. All right, so for A, it says manatees are large, gentle, slow-moving creatures found along the coast of Florida. Many manatees are injured or killed by boats. Here's a scatter plot showing the relationship between the number of boats registered in Florida in thousands and the number of manatees killed by boats for the years 1977 to 2013. So again, if I look at these two graphs, what I see, excuse me, this one graph, what I see is I see a positive relationship, right? They're going up this way. And, the dots are pretty well packed together. There's a little bit of scatter maybe right here. But other than that, they're pretty well along that line. So I'm going to say, again, that, that R is greater than 0 because the direction is positive. The direction is positive. And then, again, because the dots are pretty tightly packed, I'm going to say that R is closer to +1. You don't have to put the +1, but I will. Is close to +1, again, because it's a positive relationship. And again, that's because the points show very little scatter. Very little scatter from the linear pattern. All right. And there we go. So there's our two answers for this scatter plot. Okay, and let's try part B to the same question. So part B says to see if seat location affects test score, a statistics teacher randomly assigns students to seat locations in his classroom for a particular chapter and recorded. Oh, for a particular chapter and recorded the test score for each student at the end of the chapter. The explanatory variable is this experiment is which row the student was assigned, where row one is closest to the front, and row seven is farthest away. Here's a scatter plot showing the relationship between row and test score. So you can see that these dots are pretty much more spread. I will draw your attention to this vacant area and this vacant area. And again, I'll draw your attention to these two dots up here and this dot here. So again, I think the point is, when you go into a room, if you sit closer to the board, you learn more because you're less distracted and you should do better. So row one should have high test scores. And as you sit further back, you get lower scores. Now, you can see obviously there's a lot of scatter. So this is obviously not a very strong correlation, but there is some truth to that. So if you do go to college and you go to those big auditoriums with 300 seats, don't hide in the back corner. Okay. So I do see that it is a negative relationship. So we're going to say R is less than 0 because the direction is negative. And again, it might not be very strongly negative, but the points that I've starred lead me to a negative relationship. But because the dots are so scattered, I'm going to say that R is close to 0. And again, it's because the points are very scattered from the linear pattern. And there you go. Okay. All right, so that's objective 2. Objective 1. Objective 2 is coming.